All right, so now we're on to lesson 5, and we're going to talk about working with ArcPy geometries and other things that we can do with it. So this is going to be the overall topic. We're going to look at the ArcPy geometry objects, using geometry objects and geoprocessing tools. Not everything requires a feature class or table. We're going to look at some workspaces, the listing functions, creating data, specifically looking at some unique names, spatial reference objects, and then another brief overview of the cursor objects. So workspaces, all workspace applies to is the location of where information resides. This can be an enterprise geodatabase, which would be something like Postgres that's spatially enabled, or Oracle, to name just two. It could be file geodatabases, folders, personal geodatabases, if you remember back in the day when you were using desktop with access and stuff like that. So also SQLite databases, and this can be a pure SQLite database or a geo package. So the management section of ArcPy basically allows you to work with these various types of workspaces. And we're going to do an example here. We're going to create our FGDB. So we're going to create our function, call it, and then print it out. And we have a new file geodatabase called amazing.gdb. One thing to note when you're doing this is that when you create workspaces, especially folders and file geodatabases, if you try to create one with the same name over and over again, it will throw an error. So the next thing is, once we have a workspace that we want to work with, or we have an existing workspace, sometimes you want to know what's in there. So how do you know? It's easy to see what's inside a folder. You can go there with your file explorer, you can look at the information. But for other workspaces, it's not real clear. So with let's say a file geodatabase, how will we do that? Well, it takes two pieces of information. First, you have to import ArcPy, and from ArcPy, import env. Then you have to work with the environmental variable workspace. You define the path to where your workspace is, and then you call arcpy.listFeatureClasses. And this will print out all feature classes within that information. There's also ones for tables and other things as well, files, and a full list can be found within this slide by clicking on this link for the word here. The geometry objects are objects that define spatial location, and they're associated with some sort of shape. And ArcPy has 4 overriding shapes, and that's a point, polyline, polygon, and multipoint. And they can both be simple and complex. The class has a set of properties and methods that goes along with it. The point geometry is our simplest geometry. This is just some location in outer space. It's XY with an optional Z coordinate. It also supports M, which is for, I believe, network analyst, really. And it requires 2 steps. First, you create an ArcPy point object, and then you pass that point object into a class. So let's take a look at how that works. We have our point object. We define a location in space, and then we provide it into our point geometry and put it out. And then I'm just going to access one of those properties to represent it out in GeoJSON. Notice we haven't provided a spatial reference yet, so that WKID or factory code comes back as null or none. The array object, it's basically a container that contains points, and we're going to use this for constructing our various geometry types. We're going to use them in polylines, polygons, and multi-points. We can reuse the object to save construction time. So the time it takes to construct the ArcPy array, it's faster to just clear the information that's in there and then re-add the information as we go along. So create it once, dump out the information when not needed, and put in new. And this can be shown in the various 4 functions that support in there. We can add a single point, we can append to the end, we can remove all the points, and we can just remove a single point. Let's take a look at some creation. So here we're going to have our ArcPy and our various coordinates. We have it's like a square. For a polygon, we're going to pass an array, and we're going to create each point from our XY location within our coordinates here. So this is going to come in with our syntax doing list comprehension for XY in chords. And chords is our list of lists. And then we're going to use the star syntax to say that it's an argument. So the X is going to be the first entry in our list is going to be the first parameter for the function, and the second variable in our list is going to be the second parameter for the function, and that would correlate to XY in points. Once we have all our information stored in the array, we then pass it into the polygon object, and we do ArcPy.polygon array, and then we're just going to print out that rich syntax that we had before. To create multi-part geometries, we basically pass in multiple arrays to that object within a list. And this is how we would go ahead and we would create multiple polylines. So maybe there's a break in our road or some other line feature, but it's the same feature, and we want to represent it in one row. So we're going to go ahead and create two parts. Our first part is going to consist of 2 points and add it to the array. And the second part is going to consist of 2 points, and we're going to add it to a different array. And then we're going to create a third array from our first two, ArcPy.array, and then pass in the list of the first 2 parts. And now we have a multi-part geometry as our polyline right here. So a polyline must have at least 2 points. Unlike OGC geometries, which are what you would see if you had a GeoJSON file, polylines can both be single and multi-part. With OGC, if you have a line string, that consists of a single polyline geometry. And if you have a multi-line string, it's just like what we created before with those 3 arrays, the multi-part geometry. This means that there are less geometry types to worry about in our API. So the geometry API in ArcPy is inherently simple because they've basically obfuscated all that complexity, and you only need to know that you're working with lines or polygons or points or point. So we can take a look, and we can see that with each feature we can go through and we can append each feature to the polyline and look at the arrays. We're going to create various points. Okay. So the polygons have to have at least 3 points, and it has to be closed. A polyline can be 2 points and they don't have to close. So that's another difference between polylines and polygons. So we have 3 points and it's closed, so it makes a closed circle. It ends where the first point begins. You pass in an array and a spatial reference, and you don't have to provide the last coordinate. ArcPy will actually do that. In older versions of ArcPy, you used to have to pass in the closing geometry or you get an error, but not anymore since Pro's been released and probably 10.6 of ArcMap. Okay, so we're going to go ahead. We're going to import our ArcPy. We have our 3 points. We're going to create our array from our points using the pattern we've seen before, using list comprehension, then passing that list into the ArcPy array. And then we can go ahead and create our polygon from our point list. Multi-point geometries are an order collection of points, and the collection of basically grouping XY locations with a single geometry object. So we have our XY points. We can go ahead and create an array and pass it in. So let's see how that works and what it looks like. So we have our points. Notice the type points. We have our multiple point locations within. So we have our multi-point geometry. So far we haven't dealt with spatial references, but spatial references are going to tell where these numbers that represent our XY location exist in outer space and how they represent to the real world versus where they are now or whatever your coordinate system represents. This could even has applications when you're doing game development as well. A lot of times they'll create some sort of fake Cartesian system, so you know where each asset in your game exists at any given moment. And think of this like World of Warcraft and stuff like that. There's a whole geographic coordinate system associated with that game. When you go from various locations to locations, in reality, all the server's doing is keeping track of a point in space and then all the attributes associated with that. And then obviously all the combat and all that stuff. But so that's taking it GIS to gaming, if you want to think of it that way. But in this case, we're sticking with real world spatial references, both on Earth and in outer space and the solar system. And we have these geographic data sets, like our feature classes and coverages and even rasters, and they have to have some spatial reference so we know how to display it in the correct location. And there's a lot of areas around the world that use a lot of different types of geographic spatial references. They could be projected or Cartesian, and that has to deal, and each one has pluses and minuses for what you're doing. For example, there are state level projections, there are worldwide projections, there are ones based on UTM zone, and all these have benefits for when you're in that area. But as soon as you move outside of that location, they tend to cause great distortion. Okay, so enough about that. That's a whole different topic for another day. Getting back to programming, we're going to use the ArcPy.spatial reference object to create these spatial references, and you can either create them yourself using the ArcPy.spatial reference, or we can get it from that describe object that we saw and talked about earlier in an earlier lesson. So they're important. I went on to this a little bit before, but they're important because it identifies a coordinate system. If you don't have this, you just have a number, and it really has no context. So it gives us context of where information should be on the map, and it allows the data to be in the best projection for the job. So that's why. And there's two main types. We have the Cartesian and geographic. There's a link attached if you want to read more about spatial references. It's to a course that's provided by Penn State University. It's an open source course, but it gives a good overview about spatial references if this is an area that you feel you're lacking. There's a lot of different ways to create spatial references. One of the most common ways is to use what's known as a factory code. And a factory code is a WKID, which stands for well-known ID. When there's you can reference them from that. And I usually call, that's why you'll hear me say projected into 4326 a lot. That's latitude and longitude, WGS 1984. It's a very common projection that's used in government, federal government applications for that. We can also create from a projection file, which is it's a file that stores all this information that you see in the WKT example below in this file, and some other information. And then we have WKT, which stands for well-known text. To do that, you have to create an empty spatial reference object and then call load from string in order to get this string to make this spatial reference actually have the spatial reference that you want. I hinted at it before, but to get the factory code, the well-known IDs, or all this information, we're going to use the ArcPy describe and access the key spatial reference on our data set. We can then go ahead and get our factory code by using the factory code property. Notice with properties, you should recall this, hopefully, unlike methods, you don't put the open and close bracket on them. Open and close parentheses on them. Some other important info properties is the name, so the name of the projection that you're using, and the type. And these are going to help you in a lot of different ways, but one of the biggest reasons you would want to know this information here is because if you have to change the coordinate system that your data is in, you need to know where you came from in order to properly change it into what you have. And here we're just going to go ahead and generate two random factory codes and spatial references and then print out important information. So we're going to create from our factory code 4326 and 32145. So here we can see we have our geographic for the 4326 in WGS 1984, and then we have our NAD 1983 state plane Vermont. So we're in a state plane projection for the state of Vermont in the US. So far we've created geometries without spatial reference. In order to add that last component that we're missing to give true context to where our information is, we have to provide a second point when we generate information. So in this case, we're going to create our point geometry. So we create our point class, and then we're going to create our spatial reference. We can then go ahead and pass in with our point, our SR. And now when we do a rich representation of our data, in this case, we're going to do it in Esri JSON, we get back our XY, and then our spatial reference is 4326. So now we have a piece of information that can actually be put on a map because we have all the components that we need. That's not the only place where you have to specify where your spatial reference. When we create new data, by creating new feature classes, you need to specify your spatial reference. So here we're going to create a new shapefile called data.shape in our temp folder and specify that we want WGS 1984 along with the geometry type. And now we have our new feature class. Another component that we're going to touch on, and we'll see this as a later theme in our class, is working with unique names. Unique names are very important because a lot of times when you're doing operations, you need to, the names either have to be unique to cause errors. So by passing in this information, let's say we want to create data.shape over and over again. And we just wanted to use that as a base template. And we're just going to keep dumping our data out to ctemp. So we're going to create our first feature class as we did before. And then we're going to go ahead and queue up and get ready to create our second one. So we just do ArcPy.create name. We give it our base and the folder in this case, which is our workspace, and pass that in. And notice that instead of getting data c:\temp\data.shape, we get c:\temp\data0.shape. So the next time I pass this in, if I pass this out fc in here, when I do my create call, this would become data0.shape. Once we have an empty canvas to work on, so empty feature class, we have to go ahead and add fields to it. Because right now all we're doing is creating a table that has just the geometry column in it and an object ID field, two pieces of information that are required for ArcMap to read any spatial data. So we can use the add fields or the add field method to add columns. And you can actually add columns not only to just feature classes and tables, you can also add them to rasters. And we have allowed different types, and I'm not going to go through all of them, but some of the more common ones that you're probably going to work with are text, float, and long, and date. Text is just string characters. Float is just our decimal base. And then we have our long, which is our integers. And here's the ranges of numbers that can be stored within those various things. And then a date field is just a simple datetime conversion. So here we have ArcPy.add field, and then we have to give it a minimum of the first three pieces of information where you have the table that you're going to apply it on. So in this case, a feature class, a field name, and then a field type. So we're going to go ahead and add the field. We're going to add the following fields to it, and we're going to add one at a time. We're going to go ahead and we're going to add a text field, double field, integer field, and a float field, and we're going to use it doing the add fields method. Then we're going to print out, let's see if they actually added. So once we had it, we can see that we added that information onto the end. Now, one thing to be note about shapefiles when you're using them, in this case, the one that we're using, is that shapefiles have a character limit, and I believe it's 12 characters long, and then it'll concatenate the field name. So sometimes when you convert information, say from GeoJSON or a CSV file or some other source, or even a file geodatabase, if the field names hit that critical limit, when you try to export it to a shapefile, they'll get cut off. And that's why your data won't exactly line up. Now we're going to focus back on geometries, and we're going to swing back. Now that we've learned all this good information on how we can create data, add information to it, so we're building up this system where we're going to be able to take our analysis and create new information from it. And one thing that this is going to allow us to do, if you combine both your cursors along with the information that we showed before, is that we're going to be able to take the geometries from our search cursors and put them directly into geoprocessing tools. And it allows us to do these simple operations without having to write stuff to disk. So what we're going to do here is we're going to do a buffer, but instead of getting back a feature class, we're going to say, give me back a geometry object. So we're going to input a geometry here, a polygon, the same one that we made earlier from our array. We're then going to go ahead and we're going to buffer the distance by 100 feet and get back that geometry. And let's see what happens. We can see it from here, we got a buffer of 100 feet, and this is what it looks like. So this is all the geometries that are on there. Let's see if we can do it. This will give us the rich representation. So it just gave us the polygon. So here's our polygon feature right there that we expected. Okay, so we saw that again. Another little interesting thing we can do is that we can convert geometries directly to feature classes. And the way we do this is that we could take that buffer that we just made, and let's say we need to persist it. So we just say copy features, copy this geometry, and save it to this file. So here I'm going to save it to my Scratch GDB with the buffer, and we have our data saved to disk. Here's an example of sort of putting it all together. So what I'm going to do here in this example is I've downloaded a file called alaska.geojson. And what I want to do is I want to take each one of those features and I want to convert the geometry into Esri JSON. And then save that out to a feature class. And at the end, I'm going to print out some information just showing that I inserted the information to it. So we're going to start by doing our inputs. We're going to import ArcPy env, our DA cursor for shortcut. And that's about it. We're going to create a path to our Scratch GDB where we're going to store this. And I want to make sure that it's not in the file geodatabase. So I'm going to go ahead and delete it and create a new one with the appropriate spatial reference. In general, GeoJSON is always in WGS 1984 lat long. So, and this one is as well. So you have to define your feature class to be in WGS 1984, or your data is going to look really funny when you go to display it. And then we're going to add one field called state name. And then we're going to go ahead and read all the features within our GeoJSON and insert them into the data set. And we say for every feature inside our data, which is right here, and this comes from our GeoJSON, we're going to take our geometry, which is ArcPy, and we're going to pass into a function called ArcPy.asShape. And what ArcPy.asShape is going to allow us to do is it's going to allow us to convert that GeoJSON to the ArcPy geometry. We're then going to grab the name from the properties and insert a new row in for each part that's in there. So let's go ahead and run this. We can see that we inserted 653 rows going through, reading that GeoJSON. And I didn't have to do any manual conversion of the geometries because I was able to do it with this one built-in function as shape. I can even do the same thing here if I had a Esri geometry as well. So let's say I'm querying a feature service online, a hosted feature service or a hosted map service. and it came through as Esri JSON, I would just have to put another variable in here in the as shape of false, and then it would convert that Esri JSON into the ArcPy geometries for me. And that's something you can explore on your own. So it's the end of lesson 5. I'm going to go into a deeper example of building other information coming up. If you have any questions, once again, always please post them to the forums on Blackboard. Thank you.